Hi guys, welcome to my channel. I'm your maths coach and today we are going to be looking at vectors. You may not have studied this topic yet. For those of you who haven't, I'm going to go through the most basic principle. What is a vector? A vector is something that has a magnitude and direction. What is a magnitude? A magnitude is, for example, the size or length of something, and it has a direction. And vectors are often written like this or like this with an arrow. But before we go there, let's talk about what a vector actually is in more detail. So if I said to you that I'm traveling in a car at 50 miles per hour, I've told you the speed that I am traveling at. I haven't told you the direction that I'm traveling at. So at the moment, this is not a vector. It is scalar. And a scalar only has magnitude, only describes to you the size of something. So to turn this into a vector, I may say to you that I am traveling 50 miles per hour in the east direction. Okay, so now you know that I am traveling at 50 miles per hour and I am going to the east. I'm going in an eastwardly direction. Okay, and that's what makes this vector. So now vectors can be written like this as a column method. So 5, 2, for example. That means I am traveling 5 to the right and 2 up. If either of them, had they been a negative value, then if it was, for example, -5, then it wouldn't be 5 to the right, it would be 5 to the left. Had this been -2, it wouldn't have been 2 up, it would have been 2 down instead. So tell me what this one would be. If I wrote -3 and 1, what would happen? Right, yes, so this would mean that it's going 3 to the left and 1 up. Okay, now let's look at this in an arrow form. Going back to the first one, 5 and 2. Okay, I'm going to go 5 to the right and 2 up. So my vector, the direction that I'm actually going in, is right there. Okay, on this one again, the -3 and then the 1. So I'm going -3 to the left. So instead of going this way, I'll be going that way, 3 left, and I'll be going 1 up. So if I just get rid of this, so I'm going in this direction, and this is the direction that I'm traveling in. And that is column vectors. Right, now let's get into the nitty-gritty of vectors in geometry. And this is where you are likely to be answering questions in your GCSE exam paper. Okay, so have a look at this diagram here. We have a triangle OAB, and we are told that to get from O to A, it's A. And to get from O to B, we are using the vector here, B. Okay, and we are also told that M is the midpoint, so it's halfway exactly between O and B. Okay, so M is the midpoint of that. Now, if O to B is B, the vector B, then halfway would be half of B. So therefore, if I wanted to find O to M, what would it be? If O to B is equal to B, what would halfway point be? What would O to M be? It would be half of B. So O to M would be half of B, or you could even write 0.5 B, whichever you prefer. Okay. Now the question is actually asking us to find A to M. This is our question. Okay. Our question is saying find A to M. A to M. So where do we start? We start at A and we want to come to M. Now, how I like to picture this is like a tube map. If you take a look at the London Underground map, you can clearly see that there are all sorts of train lines and some of them cross over each other on the map. Now, if you need to get to a particular destination, you may have a certain line that is next to where you live. So, for example, you might be living next to a station that's on the district line, and you want to get to maybe a station that is on a central line. So you can't directly go from your station straight to the station that's on the central line. So what you have to do is find a point where those two lines connect. So you may travel on the district line towards into central London somewhere, and then you may find that you need to get off your train and then take another train that connects you to the other station on the central line. Okay, it's the same thing. So you can't go A to B. Can you see there's no arrow there? Okay, that means that there is no way to get there. You have to go all the way round, but you don't need to get to B anyway. Okay, you just need to get to M. Okay, so to get from A to M, I like to trace out my route. So A to M, I'm going to start at A, I'm going to go backwards. So I'm going to go against this arrow. So I'm going to go from A to O. I'm going to go A to O. And then I'm going to go from O to M. Okay, and this is my plan. That's my plan. Now if you have a look at this, what's A to O? We have not been given A to O, but we have been given O to A. We know that to go from here to here is A. So therefore to go backwards, you will write minus A because you're going against that way. Okay, you're going to do minus A. Remember, A this way is positive, going back is negative. Now, what's next? You want to now find O to M. Now remember earlier on, we already found O to M. We said O to M was half of B. So we are just going to add a half B because that is O to M. That is your answer. Sometimes a question may require you to simplify by collecting the like terms, but we can leave our answer like this. What we can also do is start with the positive. So we might do a half B and then take away A. This or that is fine as our answer. Okay, on to our next question. OACB is a parallelogram. What does that mean? That means this side is the same as that side. This side is the same as that side. They are traveling in the same direction. They are the same length. So OACB is a parallelogram. We are told that D, this point D, is such that A to C is equal to C to D, which means this length here is the same as that length here. And we're also told that this point N divides A to B in the ratio 2 to 1. More on that later because I've got another question in addition to finding OD, right? I just wanted to start with something nice and simple. So we want to go from O and we want to end up at D, okay? Now we know that O to D, you go O to A. And then from there you go A to C, C to D, okay? So A to C plus C to D. Sorry for squashing this up here, okay, but that reads OA, AC, CD. Okay, so what is O to A? O to A is right there. We are told it's worth A. A to C, we are not given anything here, but we know that since it's a parallelogram, this side is going to be exactly the same as that side. So to go in this direction, A to C rather, it would be the same as O to B. So therefore that's B. So therefore that is also going to be B. We are told that CD in the question is the same as A to C. So CD is also going to be worth B. And if you collect these vector terms up, you get A plus 2 of these B. So O to D is A plus 2B. Now let's make this question a little more interesting. This time we are going to find ON, the vector ON. Now you're here and you want to end up right there. Okay, so let's write down the route that we are going to use. So ON, this is the root of ON. We start here. Now what's the best way to get there? Now we can go here and then go backwards to B to N, or we can go from here so O to A, and then go down to A to N. Okay, we just have to decide on one of these ways. Okay, I am going to choose that we go from O to A, and then we are going to find A to N. Okay, now very quickly, we know what O to A is. O to A is A. O to A is A. What we need to find is this AN, and that's where we have to use the information that it's given us, which is that the point N divides AB in the ratio 2 to 1. What does that mean? That means that if you look at A to B and N, the position of N is this part is 2 and this part is 1 because it's in the ratio 2 to 1. Okay, so this is 2 and this is worth 1. So what does that mean for A to N exactly? How much is A to N of the overall value? There are 3 parts in total, 2 parts here and 1 part there for A to B. So A to B is worth 3 parts, and therefore A to N is equal to 2 out of those 3 parts of A to B. I hope you understand that. Okay, so just to recap what I've just done here, we are told that the A to B is split up in the ratio 2 to 1. Therefore, A to N is worth 2 parts and N to B is worth 1 part. So we want to know just A to N. We just want to have A to N here, so we can add it to the rest of our root. A to N, we've decided here that we are going to write it as 2/3 of A to B. So if we now can calculate A to B separately, okay, so what is A to B separately? A to B is right here. We can't get a direct route from A to B, can we? We have to go backwards from A to O and O to B. So A to B is going to be, instead of A this way, it's going to be minus A. So A to B is going to be minus A here, and then it's going to be plus B. So minus A plus B. A nicer way of writing this would be B minus A. That is the value of A to B. Now we want to have 2/3 of A to B. So 2/3 of A to B would be 2/3 of B minus A, because that's what we worked out A to B to be. This is essentially A to N. A to N is 2/3 of A to B. So A to N is 2/3 of A to B. And we will add this amount right here. And there we have it. We have O to A, which is A, O to A, which is A, and A to N, which is 2 out of the 3 parts of AB. So 2 out of the 3 parts of AB. Remember, B minus A is AB. Okay? So we can now leave this as it is, or we can expand it out. Expand it out. Sometimes a question may say to you, leave it in its simplest form. So you will have to do this. Okay? So A plus 2/3 times by B minus 2/3 times by A. Let me rub all of this out because it's getting in the way. Okay, right. So now we're going to collect the like terms. So 1 minus 2/3 of A. So 1 minus 2/3 of A leaves us with 1/3 of A. 2/3B has nothing to collect with, so we just leave that as 2/3 of B. Once again, you can leave your answer like this. Again, you can factorize the common terms. So the common term here that both of them have is 1/3, and that would be A. And now we need to multiply 1/3 with something here. We know B is one of them, but we want to get 2/3. We've got 1/3 outside, so that will be multiplied by 2. So that is O to N. I know that this question was very, very complicated. If there's something that you didn't quite understand, then just go back, rewind, go through the explanation. If you need me to do a further lesson on this, again, guys, write down in the comments below and I'll do another lesson, maybe break down vectors. Vectors is a very, very big topic. Usually it can take 2 to 3 weeks to study in class. So I'm trying to condense the learning here. I'm trying to give you the examples that are necessary to quickly get you up to speed on answering exam questions. Right, on to our final question, and this is a question for the grade 8s and the grade 9s. Have a read of this, because as soon as you copy down this question, I'm going to need to delete all of this text because I'm going to need the working space here. Okay, this question is probably 4 to 5 marks in an exam as well. Right, so what do we have? We have PQRS is a parallelogram. Okay, you need to remember that, write this down. It's a parallelogram. We are told that P to Q is 3A minus 2B. We are also told that P to S is 5A plus 6B. So that's P to S, that's 5A plus 6B. And we are told that R to T is minus 2A plus 6B. So these are the roots. Okay, copy down this diagram, guys, and make sure that you write these values in. What's our question? Our question is asking us to prove that QST is a straight line. QST. So if you were to draw this line here, okay, we want to prove that Q to S and S to T lie on the same straight line. So what's our strategy going to be? Our strategy is going to be something very, very simple. We are going to find Q to S, and we are going to find S to T. And when we add them together, so that's Q to S, when we add Q to S to S to T, it should give us the same answer as if we had found QST directly. So QT, if we had found QT directly. So I'm just going to rub this off now, because like I said, I'm going to need the space. I'm going to need the room to work in here. Okay, so our plan is going to be as follows. I'm going to write down the plan. Our plan is to find QS. Our plan is to find ST and add them together. And that should give us QT directly. So once again, QS, Q to S. We're going to add S to T, and that should give us QT directly. Okay, so we are going to need to find all of these separately. Okay, so let's start with this one, Q to S. Q to S. How do I go from Q to S? I can't go directly, but I know that this is a parallelogram. This being a parallelogram makes my job a whole lot easier, because see here where I've got P to Q here, which is 3A minus 2B. That means S to R is also going to be 3A minus 2B. Likewise, P to S here is 5A plus 6B. So therefore QR is also going to be 5A plus 6B. All right. So if we go back to our mission, which is to find Q to S, all right, for this one, to find Q to S, we can go QP, Q to P here, and then P to S. All right, you've got that. So QP, we know, is going backwards to this. Okay, so going backwards to that is going to be minus and that, which is 3A minus 2B. That is QP. PS is going to be 5A plus 6B, as we are told in the question. So plus 5A plus 6B. And all that's required now is to take this out of the bracket. So we get minus 3A plus 2B. So be careful with the negative signs here. Two negatives, when they're multiplied, will come out as a positive. So you get plus 2B. And then you do 5A plus 6B. Now you collect all the like terms. So minus 3A plus 5A, which gives us 2A. And 2B plus 6B, which is 8B. So what is this? 2A plus 8B. If you go back, it is QS. So that is QS. All right, make a note of that, guys. So what I'm going to do here, I'm just going to make a note of it here. I've rubbed out all the working out. So QS is 2A plus 8B. Now we need to find s to t. Okay, if we go back to our diagram, s to t, we can go s to r and then r to t. Okay, so s to t's root will be s to r and then r to t. Now, do we know what s to r is? Yes, we do. It's just going to be the same as p to q. This is in the same direction, being a parallelogram. Okay, so s to r is going to be 3a minus 2b. So s to r is going to be 3a minus 2b. All that's required for us to do is to find RT. But we are given RT in the question again. So RT is minus 2a plus 6b. So we can just write, we can add this minus 2a plus 6b. Now, you notice here how I put this into a bracket because there's a negative sign. Okay, just to be careful not to make any mistakes with my signs. Okay, and I'm now going to take this outside of the bracket. So I get 3a minus 2b, and then what's going to come out here? Okay, the negative is going to come out because a negative and a plus, when you multiply, the negative is dominant, so minus 2a, and then a plus and a plus here, so that's just going to be 6b. Now we just need to collect the like terms, so 3a minus 2a, so therefore we get a here, and then minus 2b plus 6b, we get plus 4b, and that is ST. Once again, I'm going to rub out all of this work in and just write down here that ST is A plus 4B, and the addition of those two, because I'm going to add them up. Now, what do I get when I do add them up? 2A plus A, which is 3A, 8B plus 4B is 12B. So that is the addition of QS and ST. Just to be thorough here, I'm going to find QT separately. Okay, I'm not going to assume that this is correct to be QT. This is where I have to prove, okay, that QT is the same as adding QS and ST. So let's look at the root of QT separately. So start here, Q, and we're going to end up at T. So the best and the quickest way is probably to go QR and R to T. So we're going to add R to T. Okay, now Q to R is going to be the same as P to S. So it's in the same direction, it's going that way. Okay, so it's going to be 5A plus 6B. And R to T is given to us in the question. So once again, we can just add minus 2A plus 6B. All that's required now is to take things out of the bracket. So we get 5A plus 6B, and we're going to have a negative out here again. Okay, plus 6B. Now, this is the part that will tell us whether QS, ST lie on the same straight line. Because if this adds up to what we calculated, then they are equal and therefore they are on the same straight line. So let's add this up. 5A minus 2A, that gives us 3A. 6B plus 6B, that gives us 12, that gives us 12B. So this is separately we worked out Q to T, and this is the addition that we worked out of QS and ST. We know that they are the same, 3A plus 2B, and that's also 3A plus 2B, therefore they lie on the same straight line. What you might also want to do is to factorize. So if you take this out, you get 3 bracket A plus 4B, and again, same for this one, so 3 bracket A plus 4B. And thank you for watching, guys. I hope you enjoyed this lesson. I hope you enjoyed the video. Please give it a thumbs up. Please share with your friends, your neighbors, and other parents who can also benefit from this as well. Goodbye.